I hope all of you are leaving your feedback on slido.com. If not, please do go to slido.com right away. Click on track 2 for this very track. And you can go to the session for the one that Gary just gave us. So you can please leave your feedback with us. We need the feedback for each of the presentations that we're going to have in all the tracks. So please do that. Okay, we have 6 lightning talks in store for you in these networking breaks that we are having throughout the day. So we have speakers from big tech companies such as BMC Software, VMware, Infosys, just to name a few. And this is something that you should definitely not miss. So please make note that all the 6 lightning talks are taking place on the first floor, the same place where you're having the networking breaks and the lunch break. So please do make sure that you go there and take advantage of all these amazing lightning talks. All right, ladies and gentlemen, I'll not keep you waiting anymore. It is now time for a networking lunch break. We'll be assembling in this hall right at 2 p.m. Please note, we do not have too much of time. We just have 20 minutes in hand. So please, right away, go and take your lunch. And please, from now. I hope all of you have had your lunch. Yeah, did you have your lunch? Are you feeling energized now? Yeah? You're feeling hungry, right? Because we have running a little late. But I hope now you guys are completely fresh. Cool. Well, okay. So we'll not delay anymore. We're already running short of time. So I'll start off with introducing our next speaker. So ladies and gentlemen, our next speaker for the day works as a principal technical product marketing manager at Red Hat, as well as CNCF ambassador to encourage developers' participation of cloud-native app development at scale and speed. He's obviously specialized at cloud-native app development, DevOps and agile practices, Jakarta Enterprise, JBoss products, Open Hybrid Cloud, and Kubernetes across regions. He's been delivering technical seminars, workshops to elaborate new emerging technologies for IT citizens. And today, at the DevOps India Summit 2019, he's going to speak on quarkus bringing serverless to Java developers, the topic that you can see on screen. So with a big round of applause, please put your hands together and help me welcome the one and only Mr. Daniel O.
Thank you, Ria. It's a really good introduction. Hello, everybody. So let me. Okay, cool. So yeah, so today I'm going to talk about some serverless story. So I got many chance to talk about this agenda in multiple DevOps conferences. Actually, I've been doing for 2 and 3 years as a senior DevOps evangelist. So, but many developer conference and DevOps conference more focus on infrastructure layer, like public cloud, private cloud, and Kubernetes stuff, and some tool and technology, how to monitor, how to observing the new microservice, the new application on cloud platform. But today I'm going to more focus on developer side. So I already introduced myself by Ria. So there are one thing I gotta put in I really love to share my experience and practice by Twitter and the Git repository. So if you are really interested about myself or my specialty, just follow my Twitter and you can go through my Git repository. So I'm not going to keep saying with this boring slides deck today. I'm going to show you a cool demo how it works and how to develop your microservices for your serverless application on Kubernetes cluster. So before jumping into that, I'm going to show you some developer journey for your cloud-native application development. So this is your maybe 10 years ago, maybe 20 years ago, maybe unfortunately, some people still living in the monolithic application. So monolithic application is really great. Actually, I've been doing for many years ago, developed the monolithic application. Because the monolithic application contain 100% functionality, and you don't need to repair the extra dependency to run your monolithic application. But there are two big concerns for developers. If you want to change one single function, you need to repackaging everything and redeploy and retesting, such as function tests and integration tests, performance tests, and also regression tests. So that's why, developer get starting to break down multiple modules from your monolithic application. So for example, the developer can start to develop the upload module and file upload module, file download module, and there are many modules can develop by a couple of developers. But still, there are still concerns because you need to package all module and run a single big heavy middleware. So that's why they solve just a 50% problem. Now microservice was born. Now your single module can run independent runtime like a Spring Boot and Node.js and Python, Perl, whatever you need. It's a simple, lightweight runtimes. So now we are, let's say I am the Java developers, and now I have many applications for microservice architecture, and now my application should be running on top of the cloud. So your microservice application should be along something like this architecture, distributed microservices capability, and also very complicated network of services. And also your microservices should be handled with multiple data, such as the RDBMS and NoSQL DBMS, like a MongoDB, or sometimes the data grid, and multiple entry points from the other application using the RESTful API or some end users, web browser, end user mobile devices, and also the IoT sensors. So now we arrived in function era. So some people confuse between serverless and function as a service. So I'm going to talk about that a little bit later. So this is the developer point of view, how it works, your function as a service as well as a serverless. There are many events came from in external services or some RESTful API or IoT sensors. Each single event called simple function. And that simple function called back to the application, we can call them microservices or cloud-native application. So I got many chance to meet many enterprise developers and enterprise customers. And that enterprise developer actually imagines something like this. It's Amazon Lambda. Because the Amazon Lambda is really be pervasive in the serverless industry, and as well, it's really easy and quick. Just developer point of view, they just needed to develop application like a Java, JavaScript, or Python, and just upload your application artifact, and the other rest of the all task will be done automatically by Amazon. Like creating Amazon EC2 instance and bind the network service and attach disk storage. So all behind the scene could be done automatically. So, but there are two big concerns if you are using the managed services such as Amazon or Google, Microsoft, or the other public cloud provider. Two big concerns is your company cannot go to the multi-cloud strategy. So for example, if you use the Amazon Lambda, but we want to run our simple cloud-native application as a simple function on Amazon, Google, and even on-prem, aligned with the multi-cloud strategy and hybrid cloud strategy. But it can be possible at this moment. And the other constraint is more application side. It's a dependency constraint. So in this modern application architecture, there is no restrict to develop your application for microservice architecture or cloud-native application. Maybe front application developed by the Node.js or AngularJS, and backend Spring Boot, and I'm going to talk about today quarkus application runtime and Python Go. Whatever you need, you can develop for your microservice architecture, cloud-native architecture, and running on top of the Kubernetes. But if you adapt just one single the managed service, there's always some constraint of dependency. So how to solve the kind of problem? So easy way to manage it by yourself, but it's not easy. Actually, it's really difficult to manage it by yourself. But luckily, we got some great technology in the meantime, just a couple years earlier. So Linux container is from Docker container, but we now move into OCI format container. It's more standard, so it kind of superset of the Docker container and Rocket and IBM Clear container. There are many container format, but OCI container format enable you to have more standard container format and give us some two big capability like immutability and portability. And Kubernetes, I'm not going to talk about any longer. It's a really pervasive and de facto of a container orchestration platform. And it's still service mesh. Back in 2008, the Netflix open source project and OSS, all software, give some new microservice architecture, and that in order to develop and run the microservice architecture, you need this Amazon public cloud, and you need the Jenkins server to monitor your microservice application. And also there are many software application projects such as the circuit breaking and Eureka, Ribbon, etc. But problem is you need to put that kind of the microservice capability, but it's not a functional capability. You need to put in that capability your Spring Boot application, such for example. So you need to just business application logic, just 2 classes and maybe 20 or 30 code line, but you need to put in the circuit breaker, configuration, YAML stuff, and also some annotation. So it's going to be a big burden for developer, specifically many enterprise company, and they needed to enterprise developer want to jump into the microservice architecture with that microservice capability. But there's a really steep learning curve to run about that. So it's still Service Mesh provide the dedicated infrastructure, aka Envoy proxy sidecar will take care of that instead of your application development. And last thing is this is not an option in modern application architecture. Should be exposed with the RESTful API. So, but one thing, big concern still enterprise developers is Kubernetes is not easy for developer. So one of my enterprise developer technical architect lead, he said to me, I don't want to run about the Kubernetes object. What the heck is Kubernetes YAML? It's something like similar to the JSON format because he been a long time Java developer. But definitely it's not true because if you have a mistake of some single indentation in a Kubernetes YAML file, it's gonna be definitely not gonna work. So that's why Knative was born and came up to more for developer to build, deploy, manage your microservice application for serverless, more easier way. So here is the primary component of Knative. There are 3 components: build, serving, and eventing. Actually, Knative build project already moved to Tecton project. So Tecton enable developer and IT operation team and DevOps team to build Kubernetes native, cloud native, the CI/CD pipeline. So before the Knative build, you need to some container daemon like a Docker to build container image with your application. But Knative build enable you to build container image without Docker engine. And serving provides some scale up, scale down capability. So if you have no request during some specific time, like a 30 second, 5 minutes, your application will be scaled down to 0 automatically, just like serverless capability. And the eventing, so there are producer, your microservices, and there are consumer. You got to do bind lazily. So you can add your Knative eventing or Kafka event streaming. So one thing notable is there is still service mesh as a default architecture at this moment. But it's going to be maybe disappear. It's going to be soon. So here is the how the developer what kind of the developer journey from the monolith application and modular application and microservice and jump in the cloud. And now we are arrived in function. And all technology, Linux container, Kubernetes, and the other architecture and technology, all more focused on upside in DevOps infrastructure. So I'm going to a little bit more talk about application side. So all application runtime like a JavaScript or Java and like a Spring Boot, all microservice application runtime was born both for Linux container technology and Kubernetes technology. So that's why always specifically Java have us keep fighting with the optimization. So how to packaging, how to the containerization your application on your scalability on Kubernetes infrastructure. So that's why the quarkus came up to fix that problem. So quarkus, we can actually the Red Hat invented this upstream project, and we can call that Supersonic Subatomic Java. It's a Kubernetes native Java stack. So I'm going to call, why we call that, let me show that thing. And also, the Java developer and Java application should be evolving to more fit in cloud-native application and microservice application as well as the serverless application. So let's see, I'm going to show you a quick demo. So one of the easiest way get started with the quarkus application is definitely Java. So there's no learning curve to learn about in the quarkus application. So one of the easy way, maybe if you are a Java developer, specifically Spring Boot application developer, it's really easy to go to the Spring initializer and add some dependency and download the G file and extract and let's get started. So it's a similar thing, but more than that, you can add some REST EG. I'm going to add the REST EG and the REST client. And also, I'm going to put in the data resources, you got JDBC H2 driver and MariaDB. And after the generate application and download G file and extract, and let's get started with your prepare IDE tools. So actually, just my demo time, I already download the application here. So I'm going to use the my IDE tool, the VS Code. So once you download at the default the application from the code.quarkus.io or there are some quick restart. I'm going to show that later. So once you get started to the Quarkus application, here is the Quarkus latest version, here 21.1, but we're going to release 1.1.0, the upstream project, the end of September, actually next month. And there are some dependency libraries like REST EG and Java unit test. And we're going to use the Maven plugin, which means all developers can use the Maven command to compile, build, deploy, and packaging. And there are some native profiles. So I'm going to show that thing, what native image is. So let's say I'm a Java developer. I just pull down some scratch from code.quarkus.io. So I wanted to make sure this default application functionality. So how to get started? Just Maven, compile, and Quarkus, and dev. But for running is that here is a sample application. Here's the Java directory, and here. So this application just exposes the hello, the entry point, and endpoint as a return hello. So let's get started the application runtime. So it's already run, and we just needed 1.3 seconds run this application, and back to the local, the browser and running localhost 8080. So there is a welcome index page. So go to the REST endpoint, the hello. I'm going to zoom in. So it's a hello. So let's change the code. So I'm going to change the code return value. Welcome DevOps India Summit 2019. and I'm going to save that and back to the web browser and reload the application. Just change that. So, but I didn't even restart my application runtime, and I don't even recompile. It's all automatically done. And I just need here 1.6 seconds to do that. So this is one of the good benefit to increase developer productivity in cloud-enabled application development. So I'm going to shutting down my local environment and back to the local, web browser to make sure server is down. And the next step, so I'm going to already done, let's say I already done the develop the cloud-enabled application. The next step to deploy the Kubernetes cluster actually on top of the Knative. But in order to that, I need to package my application artifact. People already know that the Uber one fetcher. So how do the clean package? But I'm going to skip unit test because the unit test expected return hello, but we already changed the code. So I'm going to clean package create the application artifact like a jar file in a Uber jar. So already done. We need just 5 seconds. So there are target directory. So we have here Uber jar. And buffer running the Java application based on JVM technology. So okay, maybe we should zoom here. Okay, so this is the activity monitor in MacBook. You can see how many memory footprint used by the Uber Java based on quarkus application. So I'm going to see they're using Java here. So this is the default running to JVM. So back to here. And once again, the target directory. And this one is our fetcher. So running application using Java command and target directory here. So we just need the 0.7 seconds to run this the Microsoft application. And back to the browser and just running, the function is totally working. And back to the activity, the monitor. And once again, here. So this is simple application, just explore the RESTful API. The memory footprint almost 100 megabytes to run. So just keep in mind that I'm going to show you more cool thing. So I'm going to shutting down. So next step, we need to containerize this application. But for that, I'm going to show you another quarkus good benefit. You can create a native image. So native image means executable image, just like a Go program language. So don't need to dependency library. So JVM already using the JIT compiler strategy. So during the time you have just bytecode, and the runtime you need the dependency library should be running on top of your memory, like a heap memory. But in the native image, we need to create a native image, and we all dependent library put in that single executable image, and we're gonna run on top of the GraalVM, not JVM. So just using profile we saw in the POM XML. So it takes a couple of minutes to create a native executable image because there is needed all dependency library, just the ahead of time, the compilation strategy. So gonna be a little bit take some time, but this needs just one time to build. So during the day, it will be boring, so I'm going to show you another cool thing, how to get started quarkus application if you are interested after this talk. So here is quarkus.io. It's the upstream open source project, our official page. And there are some interesting is how to get started, the develop quarkus application. Once click on the get started, here is the building native image, just I mentioned about that. So take your application, maybe Java application, and produce a native image, and also run it. And once you click on guide, and there are many content, such as the use case based, how to create a core application, how to create a web application using REST API functionality, and how to data transaction for using the JPA or the Panache. It's really interesting and really easy to connect to your database. In the messaging, how to connect to your application, the Apache Kafka. So no need to add many configuration file, just add annotation in your Java class and Java method. Just checking in back to here. Yeah, we just done. And go to the target directory. Here is the running the executable image. And just to make sure, the target directory and here. So one notable thing is you need to be aware that when you create your native image, that native image file only running on the operating system where you build. So in this example, I just built that native image on my MacBook Pro, which means this image only running here, MacBook Pro. So just to get how to get started that application, target here, C. So it's a MacBook security policy here. See, we just need 12 milliseconds to run this application. So people say that Spring Boot application or the other some running Java application really fast in a microservice architecture because it just needs to start up a couple of seconds. But this is maybe hundreds of times fast or 1,000 times fast. And even when I get restart here, so memory already allocated. Here's a 7 milliseconds to run. And back to here, the local environment, reload. Yeah, it's totally working. So I'm going to shut it down. And now we're going to go to containerize this application. Yeah, but for that, so in my the Kubernetes cluster actually running Linux operating system. So which means this application, the native image based on Mac OS is not going to running on Kubernetes cluster. So that's why I'm going to add the ones that are going to be packaging this application to run the Linux operating system. So during that time, I'm going to show you, this is our Git repository. So go to the github.com and quarkus.io. So here is the quarkus quick starts. So once you click on the quarkus quick start, there are many examples, like how to get started, asynchronous application, how to get started to develop the Knative application. So actually, I'm going to use the quick start example today, but I'm going to tweak a little bit because to make it short in a demo time. So back to here. So during the time, so I actually running my local Kubernetes cluster. So it's a menu shift. It's based on Kubernetes and already on OpenShift container platform. So one of the interesting is, so Minishift provide a web console. So I already talked about the Knative needed to STL service mesh, and there are default primary components such as building, serving. So once you go to the building, I already deployed to save my demo time, and here's the serving. So one other thing is that you go to the config map, it's a configuration and Kubernetes, and the config map, there is a config autoscaler, and here we go. Autoscale to 0 grace time period 30 seconds. This is a default value, which means when you deploy your Microsoft application for serverless, and there is no request during this time, your application will be scaled down to 0 automatically, just like Amazon Lambda. So let's see that. Okay, and also I already deploy STL service mesh, all the dependent library and component, ingress, egress, pilot, Sidon, etc. So today I'm going to use here the quarkus on Knative demo project. It's a Kubernetes namespace, but there's nothing in here because I didn't even deploy any application at this moment. So back to here. Yes, I think it's almost done. So, and how to make it fast in Quarkus application with the native image, because we are using GraalVM, And actually, we are not using every single detail of GraalVM features. We just only using GraalVM compiler and under the substrate VM to run super fasting. And just done, and I'm gonna make sure the file format here. Now we have an executable image based on the Linux operating system. All right, let's create the container images. So, but I'm going to use my Kubernetes, the Docker environment. So using the Miniship Docker environment and the build, Docker build. So how to build Docker build? Here's Docker build. So using the Docker build command, and I'm going to tag here because there is Knative using Kubernetes custom CID custom resource definition, something like this. And the only thing is I'm going to put in the image tag, the dev local serverless reader. I just created that. Yeah, still working on the Docker build. And this Knative directory and service YAML file is automatically pulled down when you using code.quarkus.io and you add the Kubernetes Knative capability. And just to make sure Docker image greater. So we have the application. So now I'm going to deploy the application using this service YAML. And I'm going to split my terminal and kubectl get path. So there's nothing here in the pod. And I'm going to run this the service YAML deploy application. And they're going to be automatically deploy our runtime application to Kubernetes. Back to the local environment already run. And here, the log file. Yeah, we just 21 seconds. The 40 milliseconds to run the application. And back to here, local environment, I'm going to make sure to run the application. So in using Istio service mesh, they need to ingress gateway. So now the function is totally working. So back to the environment. So just let's leave it there to scale down automatically more than 30 seconds. So actually, I got a couple of slides that to summarize today's session. So just imagine you can use the Knative or Kubernetes to build, deploy, manage your serverless application. But what about the application side? So there are many application runtime, Java, Python, and the others. But if you are interested in developing cloud-native application or microservices based on Java technology, maybe Quarkus is a really good answer for you, because just imagine some application needed to run 10 seconds or even 30 seconds, but some applications should be just a millisecond. So there are, so that's why we call the Supersonic Subatomic Java, but Quarkus, because of small memory footprint and small size application and super fast starting time. And one notable thing is that you can develop Quarkus application for imperative, like a traditional way, as well as the reactive system. Just add some the annotation, for example, Kafka annotation. So there are many open source projects already joined the Quarkus, the framework. You don't need to worry about how to integrate, for example, how to integrate Prometheus to monitor my cloud-native application. Just add the extension and just put in some simple application property, gonna be work. So a couple of resources here. So I published a lot of articles about how to get started serverless application framework, and there are the tutorial to how to get deploy, manage the Quarkus application for serverless and function as a service here. So back to the local environment. Yeah, it's terminating, and back to here, the OpenShift console and dashboard here. Yeah, it's already terminating during it's already more than 30 seconds during the we talking. So just one last thing is, when I call this application one more time, and back to here, the application based on Knative for serverless application should be running automatically or something like this. Just we need to more than 1.5 seconds. Just imagine that which application runtime would be appropriate for your serverless application. So I think I'm running over time. Okay. So yeah. So thank you. And I'm going to go to back there. So if you have any question about this, just let me know. Thank you.
All right, thank you, Daniel, for that wonderful session and for giving us this live demo. Let's have a big round of applause for Daniel, everyone. The very few speakers who's given us a live demo. All right, Daniel, before you leave, stay back for some time. Can I request Sanjeev Sharma from Delphix to please join us on stage and present Daniel with a certificate and a memento.
What?
Over here.
Oh, yeah. Yeah. I didn't even know. Thank you.
Great session.
Oh, yeah, thank you.
Yes, we can make some noise, everybody, for Daniel. Come on, everyone.
Thank you.
Joining us all the way from the US.